Let's now take a look at another example. Suppose I'd like to solve the triangle, and suppose I know that side B is 84 centimeters, side C is 65 centimeters, and angle A is 36.4 degrees. In our final answers, we're going to round our lengths to the nearest hundredth of a centimeter and angles to the nearest tenth of a degree. So the first thing I do is I sketch a model triangle, and so I've been using the same triangle, and what I did here is I put in red the items that I don't know. So I don't know angle B, and I don't know angle C, but they gave me angle A, and I don't know side A. Notice they did not give me any information that would give me a matched set, and that's always an indicator to me that if I'm dealing with something that's not a right triangle, that I need to use the law of cosines. So the only side I don't know is side A, so what I'm going to do is find that first. So if I use a variation of the original law of cosines formula, I'd have a squared equals b squared plus c squared minus 2bc cosine A. And I'll put in what I know. I know b squared and c squared, so that's 84 and 65, so I have 84 squared plus 65 squared minus twice 84 times 65, and then times the angle, and they told me that the angle, angle A was 36.4 degrees, and if I put that in my calculator and do the math out, I learn that a squared is 2,491.6 basically. And when I take the square root, using all those decimal places, I get 49.92. And remember, we take the positive root because we're dealing with lengths of a triangle. So just a couple of comments, and I've kind of alluded to these before, relative to the calculator. Make sure we enter the entire right-hand side in one step, and make sure that you do not round. And then also, one of the errors I see students often do is they get so excited that they've done a squared and they've managed to put all that in the calculator that they forget to take the square root. So what we're going to do is continue to use variations of the law of cosines instead of mixing in the law of sines, because we technically haven't really talked about it yet. And so let's take a look. So now I'm going to find angle B. And so I'm going to use the angle B version. So I'm going to use b squared equals a squared plus c squared minus 2ac cosine B. And so I plug in what I know. I know A, B, and C all now. The only thing I don't know is cosine B. So I would have 84.0 squared is 49.9 squared plus 65.0 squared minus 2 times 49.9 60 times 65 cosine of B. And if I solve all of that like we did in the earlier example for cosine B, we get that cosine B is 49.9 squared plus 65 squared minus 84 squared over twice 49.9 times 65. And when I do that, I get negative 0.05256513.026. And remember what we said we need to do to find the angle is take the inverse cosine. And so when I do that, I get an inverse cosine of 93 degrees. And now we know our one angle, and now we know a second angle. We could actually just subtract now to get the third angle, and now we know all sides and all angles. You'll probably want to go back, because I went through that kind of quickly, take a look at your notes and solve the problem. Make sure that you feel comfortable with it.